If you've been paying attention in your Algebra 1 class before, you've probably seen this type of equation before. Now, this, as you probably might know, is a linear equation. And to solve it, simply add 5 to both sides, which leaves you with 3x equals 15. Then divide by 3 on both sides, which leaves x by itself as 5. And ta-da! That's your solution. But maybe if you haven't gotten as deep into algebra, you're probably not familiar with this type of equation, which at first glance might look a bit intimidating. But I assure you that after this series, this type of equation will not look as intimidating as it had at first glance. Now this is a quadratic equation, which will be the focus of the next few episodes. Now, of course, this series won't just focus on quadratic equations, but more quadratics as a whole. Now, a little bit about quadratic equations. So, quadratic equations take this type of form, which is ax squared plus bx plus c. A is the leading coefficient being multiplied by x, which is getting squared. And b is the middle coefficient getting multiplied by the same variable x, and c is the constant term at the end. But briefly, I would like to talk about the importance of quadratics in our everyday lives. For an example, think of a baseball pitcher and a baseball batter. Now the baseball pitcher throws the ball, and the leftmost point on this coordinate plane is where the baseball hitter makes contact with the ball that was pitched. Now we can roughly map out a trajectory, which is this parabola that I've graphed out. And the topmost point is the maximum altitude of the ball hit. And this topmost point is also called the vertex, because so far the parabola has been going up. Now at this point it changes its direction and starts going down. And then the rightmost point is where it makes contact with the ground. Now this is one of the most common examples of quadratics in our modern day world. After all that, you're probably wondering how to solve the equation that I had shown on the screen previously. Now, in this episode, I've given you an introduction, and the next step forward is to introduce the first concept, which is factoring. Now, this is definitely one of the most important concepts when you're solving quadratic equations. But first, you need to make sure in your quadratic equation that your quadratic expression is equal to 0. We can simply do that here by subtracting 6 on both sides, which will result in 2x squared minus 5x minus 4 is equal to 0. Now comes the factoring part. We factor only the quadratic expression. But before we actually start factoring, I'd briefly like to talk about the different methods that you can use to factor quadratic expressions. Now here we have grouping, difference of squares, and perfect squares. Now I hope you've at least heard of one of these. If you haven't, that's fine. Maybe you've heard of 2, or maybe you've heard of all 3. Regardless, for this quadratic expression, we will be using grouping. Now, out of all of these 3, grouping is probably the most common one. It's used when the leading coefficient is greater than 1. So our leading coefficient here is 2, so we would use grouping. Actually, I would like to divert from this equation to a different equation because of the fact that this equation isn't the best example for grouping. Next equation is 4x squared plus 4x minus 15. So, on to the factoring. To factor a quadratic expression using grouping, first you have to find out two numbers that multiply to the product of the leading coefficient and the constant term at the end. So in this case, you would have to find two numbers that multiply to 4 times negative 15, which is negative 60. And these two numbers also have to add up to 4, which is the middle coefficient. We have negative 6 and 10. Negative 6 times 10 is negative 60, and they both add up to 4. So the next step would be to split the middle term, which is 4x, into negative 6x and 10x, because those were the two numbers that we found out that multiplied to the product of the first and last term and added up to the middle term. So if we split that up, we get 4x squared minus 6x plus 10x minus 15 is equal to 0. Now make sure to line these up conveniently so that when we split the expression, you have a greatest common factor on each side. So we split the expression into these two smaller expressions. Then we can use the greatest common factor to factor out each smaller expression. So with that, we get 2x times 2x minus 3 plus 5 times 2x minus 3 is equal to 0. So now you might notice that in both of the smaller expressions, there's another common factor, which is 2x minus 3. So we can also factor that out, so we'll eventually get 2x plus 5 times 2x minus 3. Now, in a quadratic equation, we have two solutions here in this specific quadratic equations. You can see this because of the fact that there are two expressions, 2x minus 3 and 2x plus 5. And they both multiply to 0. So that means that either one of those smaller expressions can be equal to 0, and this equation will be true. So, assuming that each one is equal to 0, we can find out the two solutions. So if 2x minus 3 is equal to 0, x will have to be 1.5. Because if you substituted that within the 2x minus 3 expression, it would be equal to 0. And we can do the same with 2x plus 5, and x would have to be negative 2.5. So those are our two solutions. And ta-da! You just factored a quadratic equation and solved it. So on to the next example. Our new equation here is x squared plus 5x plus 6 is equal to 0. Now here, you might notice that the leading coefficient is equal to 1, but the same principle applies. The two numbers that you split the middle coefficient into have to add up to 5, which is our middle coefficient, and multiply to the product of the first leading coefficient and the constant term. This time, you can just do to the constant term because the leading coefficient is 1, so even if you multiply the constant term by 1, it will be the same number. And those two numbers are 2 and 3. So our new expression becomes x squared plus 2x plus 3x plus 6 is equal to 0. And then we can factor out an x in the first half of the expression, which leads to x times x plus 2, and then we can factor out a 3 in the second half of the expression, which also leaves an x plus 2. And then we can factor out an x plus 2, and that'll be x plus 3 times x plus 2 is equal to 0. And finally, to find the two solutions to this equation, if the x plus 3 expression were to be equal to 0, then x would have to be equal to negative 3. And if the x plus 2 expression would have to be equal to 0, then the x would have to be negative 2. And ta-da! You just solved your second quadratic equation. And finally, the last method to factor that I will be talking about in this video is difference of squares. Now, I'm sure that at least some of you have heard of this method, as it is very popular and talked about a lot. So let's dive straight into it. So the premier example of difference of squares is this one on the screen right now. A squared minus b squared. Whenever you find an expression in this form, you can use a difference of squares. So right here, a squared minus b squared, you can rewrite that as a minus b times a plus b. So with that, we can apply it to some other examples. So here we have x squared minus 5 squared. So we can, as probably most of you know, write it as x minus 5 times x plus 5. And we factored that expression. Now, difference of squares pops up a lot when you're factoring quadratics, so it's really important to know. And finally, that is the end of the video. So I hope you learned how to factor quadratic expressions in this video, and you'll definitely see the importance of this skill later on in this series, because factoring is a huge part in the field of quadratics. But with that being said, I hope you enjoyed the video. Subscribe, hit the like button, comment down below, and I'll see you next time. Bye-bye.